The idea here is that we're talking about an electronic manufacturing technology program. If you really narrow it down, we're really looking at taking the semiconductor and producing some kind of a product out of it. But in the education side, the students, they want a project. They want something that's going to move, make a light, make a sound. It's got to have, it's got to have something. But in it is their whole process, the whole manufacturing process to be able to produce, bring components in and be able to produce a product out of it. And this is what industry is going to feed back in, saying what skills they really need to have along these. And when we talk about skills, I divide it up into, and we do this at the university level in our curriculum, is we divide it up between what's called an engineering science, and then also a design aspect. Or if you want to think of it as one's kind of in the training world and one's kind of in the education side. So education, the term education and training are specifically different. We want to have, and I'll give an example of, let's say you're going to solder something down. It's important for the students to be able to understand general science behind how molten metals work, but then how you actually go through profiles, how you actually do the mechanics of it, the kind of equipment you use, etc. That's the training aspect of it. In the with SOLOXR, they represent very heavily, very intensive, very submersive uh, uh, um, augmented reality, virtual reality tools. And so we're going to use those tools not only to be helping in the education side, but we also want to have those tools being used on the postgraduate side. And it's also going to be how they're going to do homework if you're talking about some kind of a physical system. So again, the most important part that we want to see is going to be what Carolina Community College, this is okay, so the other part of this is a 2-year pilot program. And in that 2-year pilot program, we would like to be able to establish what we want to proliferate across the entire nation. And I'll show a little bit later about what the game plan is for proliferations and why we have universities on this call. But for Central Carolina Community College, they're the ones that are really tasked, and this whole thing is focused on rural community colleges. We also will pick up the urban community colleges, but typically they're located heavily within tech centers. There's a lot of drive, they have money, but the rurals are the ones that have very limited funds. They're the ones that have very limited human resource. They're the ones that are always under the gun to be able to try to bring economic development into their areas. So the community college systems are the ones, again, they're the main attraction. And what they do is they produce the students, which will then go into industry. And please, anybody that wants to chime in, please chime in and to be able to accentuate a lot of what's being said. If we look at what the community college needs, they need to have an educator. An educator, and I have the parallel to every chemistry teacher as a chemistry lab. So we're going to be able to develop this at the community college level. And the educator has to be developed to be able to work within to be on the faculty and work within the community colleges. So NC A&T is going to be developing, and at this point, we're calling electronic manufacturing technology educators. Now we can change a lot of this. We're still developing and sending out in 11 August will be our initial submission of intent. And if we get it selected, then we go for the proposal. So some of this can change if you want to see it change, but also we look at this to be massaged and even tuned to different community colleges along the way, but the fundamentals will all be there. So AT&T produces the educators that Central Carolina Community College is going to want to use. And there might be other groups within North Carolina, or could be if people want to jump on board elsewhere too. And then the other part of this is that we talked about chemistry teachers needing a chemistry lab. Well, what we're producing is, we call it the EPack-LAB in a box, electronic packaging laboratory in a box. And this is something that will be a physical resource that's deployable to the community colleges. So again, chemistry teacher, chemistry lab. the Electronic Manufacturing Technology Educator, the Electronic Manufacturing Technology Lab. And then these labs will physically exist. Now, in the pilot program, well, before I do that, let me mention that. So NC State University takes the lead. And we've been, and essentially these,
Hello.
hello, can you hear us? We can hear you.
I know.
Okay.
Yeah, we can hear you.
Okay. And so NC State takes the lead. And of course, we've been doing this at the university for quite a while, this whole electronic manufacturing technology program, but basically how to be able to take a semiconductor and make it into a product. That's coming out of my lab and the curriculum, actually out of Dr. Rue's in my lab. So in this, we're going to be helping develop the technical curriculum for NC A&T and also for Central Carolina Community College. And of course, besides just technical curriculum, and I said technical on purpose because there's a whole educational aspect. I mean, we're developing teachers that have technology backgrounds and technology understanding and can work in the labs. And there could be other people that could help out at the community college level, as Margaret has helped introduce me to the fact that they use second and third career type people that actually have technical backgrounds that can help to be technicians in the box, so to speak. As I mentioned before, and what we're going to do for the pilot is we already have a box. That's the lab that's the lab that John and I have here at the university. It has all the components to be able to do everything we plan on doing. And this is on the bottom right-hand side is a representation of what we do is starting out with bare semiconductors, making circuits then make systems. And this is the process that students then can end up having something that would be makes a noise, lights a light, or moves. And in this part is actually looking at how to be able to deploy the lab in a box system. And these are basically containers, shipping containers. These are the 40-foot by, I think, 20-foot or whatever they are, 8-foot, I think, 8 by 20. And it fits in there. And so two boxes or two of these containers side by side is a box. These are deployable, and again, and tutelage from Margaret mentioning that community colleges only have 2 to 3 years to be able to prove a program. And so these boxes are not cheap, and they most certainly, when they get one, they're not going to be, if they can't have a successful program, we want to be able to see how to remove those boxes and have them refurbed for the next community college. But in that light, yes.
Just a couple of quick questions here. This looks exciting. Question number one is the main aim here for technician training? And I'm thinking, so it's not so much, or maybe there is some engineering or engineers being trained here, but we are really focusing on technician training. And this idea of the lab in the box and that container, would that be budgeted in this project, or is that I'm just that
Yes,
could
yes,
be
yes.
quite expensive, but I'm just wondering how the
Exactly.
that would work.
Exactly. And that's one of so the engineers and the techies are fully going to understand you have to have a box that's going to be, somebody has to design it, they have to deploy it, they have to install it, they have to warrant it. So that in itself is going to have to be a business model.
Yeah.
We need some company out there, or maybe two, but again, it's the business model, and that's why Rob is on board, that somebody's going to have to step forward and do that. And,
Okay. Yep.
right. And so that's an important focus for us to have. And so in the pilot, what we'd like to do is to identify a company or two and have them be able to produce a design that can be then manufactured and carried through with deployment, installation, and warranting and maintenance. So for the first 2 years, I think if we can accomplish having that fully described with a company on board to want to deploy it
Yeah. Okay.
with a business model, I think it's perfect.
Yeah, yeah. So the box is part of the deliverable as such, in partnership with industry as part of the program. Yeah. Okay. Thank you.
But we're only going to commit to a design. We're not going to commit to an actual box.
Okay. Thank you.
Manufacturing's later.
Yeah.
And you also said as technician, and that's right. We're looking at how those that can operate and maintain. I also had install, but I use the word installation a little bit carefully because when you say installation, you get into pipe fitters and you get into all this other stuff. So I narrowed it down to we want students that can operate and maintain this kind of equipment.
Yeah.
And we have Dr. Yi Zhang on board from Applied Materials, and we have Amy on board from Micron. So we do have people that are looking at this on how they would want to be able to tune this whole system to what their needs are.
Thanks. Okay.
And then the other aspect, and I mentioned earlier, is that if this is going to be sustainable, it's going to have to be industry driven. Eventually, one way or another, industry is really going to be the lead on this. And these are pretty much for-profit industries. And so SOLOXR has jumped in. They're the ones that are really pushing this. They have already been out talking to different other companies, organizations, etc., on bringing in industry-oriented influence into what has to be done in the tech curriculum. For instance, they've been talking to IPC, and IPC is very much involved with this. We're going to also bring in IEEE, Pat McCluskey, Professor Pat McCluskey's on. He's on the board of directors of Electronic Packaging Society. We're going to bring IEEE in and try to open this up so that we get more people coming in from industry to influence.
So is Chris, by the way. Chris is the ex-president, so former president. So he has a little bit of pull too. So yeah.
Okay.
I'm one of the old guys now. They found me out.
Yes.
But,
well, that's why I wanted you on, Chris, because this is I'll say, and I'll skip forward because you guys are piping up in that. Let me just finish that to the last slide real quick. So SOLOXR is the ones that are going to be able to provide this augmented reality, virtual reality environment that you'd have for students going home and doing homework. They'd be able to say, hey, okay, for these boxes, they're going to have to be low cost. So they're going to be, and I look at it as if you want to be able to know what's inside happening in a machine, why don't we go with a little bit of low-tech approach so they have more hands-on. So you might have semi-automated systems. And then through AR, VR, you can then go and upgrade that and say, hey, if you're going to operate on, and then you can recommend a machine and say, okay, this is what you'd be doing if you were doing a fully automated system. But they know the fundamentals, the engineering science, and the fundamentals and the training and the hands-on at the kind of the lower level to understand what is done behind the screen, so to speak. And so that's SOLOXR's initiative, is to be able to help bridge that gap and then bring them along. And they go further, which is really nice, is that they then say, now, wait a minute, we have a whole nother plan that these graduates will probably need upskilling as time goes on. And the companies themselves will need to have better skill set brought into them, or they themselves have workers that need to be upskilled. So that would be something that they would take on through the AR/VR, and that could even feed back into the community colleges. I don't show here a pathway where the industry is actually feeding back to the community college what they need, but there has to be that feedback, and I know that'll be an important arrow, but I already have enough arrows on this thing.
And by the way, just a point there is that's an area of specialization for Amy, who happens to be at Micron, but she literally lives that role on a daily basis.
Perfect. That's what we need. And then the other part that's attractive, because the initial part of this is workforce development, but I also put in my original ideas was workforce and economic development, because the community colleges are there for economic development. Those regions need to have the community colleges as part of their economic ecosystem. So they might end up, in some cases, being able to have a redefined box that could be a commercial prototyping capability where their students could run the box, or it may be done by a small company that's heavily interleaved. And this is what they do in Europe. Europe takes schools and heavily integrates them in with the industry. And then that box could be a resource to industry itself as a prototyping capability, as a small business. And of course, the box over here could be that the company, or it's been recommended to me, and I forget who from SRC, but the military often want to have a box that they could produce things in that nobody's eyes see, you know. So there's a whole aspect there that would be a one-liner on their proposal as a potential. So that pretty much is what goes on. Let me skip forward, then I'm going to come back because I want Rob to talk more about what they're doing. So the other part of this is how do we proliferate this? And not in the pilot, but that's why I have the universities on board. I think that this concept, as it develops, we need to have an army of people that are going to help proliferate this concept. And so I want to go to the land-grant universities. I had land-grant, I took it out, I need to put it back in. Land-grant universities who have a heavy tie to the community college system within their states. I also want to go to the national labs who also have a heavy outreach. And then we also need to include the national programs like CLAWS, the stuff that we have at Arizona. These are critical to be able to have them see that this is a platform that we ought to have a lot of people behind. And then, of course, we have, like I mentioned before, Rob's brought in IPC and some other organizations that would have recommended curriculums and certifications and credentialing that can happen to all of this. So at that, I'll ask Rob to make comments now, but are there any questions or comments? Or Margaret, would you like to say anything?
Doug,
Okay.
I just got a question on, we talk about electronics manufacturing, and I'm wondering how wide that scope is. And obviously the box is going to be designed, and I guess the actual manufacturing processes would be based on that, on what the project comes up with, what should be in the box. But obviously there's power electronics packaging, there's surface mount technology, PCB designs. I'm sort of wondering, do you have a sort of feel, are we going to be very broad in this? Maybe
Okay, so
there's a bit of
no,
a focus.
Yeah, no, that's perfect. Because so what my lab does too. So we will take and operate at the bare die level. And then from there on going through. So you'll have bare die goes into a package. Packages will go on printed circuit boards. Printed circuit boards will go into the systems that make things move. We do bare die, but the reason is because in the box, you want to have a class 10,000 or class 100,000 environment. So they have to learn clean room technology, clean room techniques. You also have to have ESD techniques. So the box will have ESD. So they'll learn clean room, they'll learn ESD. They'll learn how to deal at the semiconductor level, at the chip level. They won't make semiconductors, but they'll be using the semiconductor. So how do you deal with somebody? How do you move semiconductors? How do you, all that stuff. And then it's the assembly process of taking the die, putting into a package. And then from there on is the SMT process. How are you going to be able to mount down your die? Or at this point, you could just drop in and say, hey, we're doing, printed circuit board manufacturing, assembly. And then from there, you go into the actual circuits, which could be DIY type of systems that keeps it exciting for the students, but they're getting that manufacturing flow. Now, I know that Ahmed from, I think Northeastern, whatever, he has NanoOps. They have a box that actually using direct write to make integrated circuits on bare wafers. The box, you bring a wafer in, you do all the magic inside, and out comes an integrated circuit. So there could be in the future, we're not promising it here, but I know that there's so much focus on how do you make semiconductors. We're trying to go the next step past that, is that you could add a third box and say, now we have the ability to actually make semiconductors. But I'm not sure how the community colleges looking at economic development would really benefit from that at this point. I think what they need to be able to do in a rural setting is to be able to have more electronics engineering and manufacturing than trying to be able to zero in on a semiconductor fab. But that
Yeah.
said, that doesn't rule it out. Once we get the platform down, then we can start adding on these other pieces. Or if somebody wants to take the initiative, do a parallel with us, and then you know, exactly the same process and have it for how to make a semiconductor.
Yeah, okay, no, it sounds good. And I guess at the package level, I mean, this is technicians, isn't it? So
Technicians.
in a way, they need to understand, you know, how a flip chip bonder works, how a wire bonder works, and how you may be maintaining that or gathering data from that. So I guess that's where we are, aren't we?
Yeah, there's metrology, the whole metrology aspect.
Yeah, and then obviously with thermal structures and that sort of thing, how to do or gather data on that.
Right. And you've got a good perspective when you think about it. If you look at the process of coming up with a substrate, which the IC with the semiconductor people call a wafer, and we call a substrate either a piece of ceramic or a printed circuit board. You know, we're using the same technology. And then you go ahead and make integrated circuits. Semiconductor people make the integrated circuits inside the wafer, and we make our circuits on top of the wafer, right? But the processing of how you lay things out or how you put down, you know, formal coatings or if you put down coatings of any kind and how you do patterning and all that, those processes are pretty much the same whether you make an integrated circuit or you're making a full electronic circuit. So I think we'll find a lot of synergy between those two.
Okay.
Okay. Rob, you want to jump in and then tell
Yes,
us more about
absolutely.
the
No,
industry
that
side?
was great. And I think what I'm going to do is I'm going to take the first 5 minutes because not everyone on the call knows each other. So if you just say your name and what organization you represent, that'll be enough for now, but it'll at least allow us to understand who's on the call. So I'm Robert Sherman, CEO at SoloXR. I'll call each of you to keep it coordinated. Everyone knows Doug Hopkins, and maybe Doug, tell us though your title and what you're responsible for.
I'm a professor and I also direct the Laboratory for Packaging Research and Electronic Energy Systems called PREES. In my area is in power electronics.
Very good. So Christopher Bailey.
Yes, hello everyone. Christopher Bailey, a professor at Arizona State University with a focus on packaging.
Wonderful. Andy.
Andy Rittenauer, professor at Western Carolina University, sort of a semiconductor device engineering background.
Wonderful. Welcome. I'm Benson. Benson Chan.
You are. Hi, Benson Chan, Associate Director for the SRIP at Binghamton University. So we basically do research on electronics packaging and also part of the IEEE EPS board.
Very good. Welcome. Sam Hadla.
Yeah, hi everyone. Nice meeting you. I'm Sam Hadler, CTO of SOLOXR.
Good stuff. Jennifer.
Hi, I'm Jennifer Comer with NC State University. I work in the proposal development unit.
Okay, great, Jennifer. Good to meet you. Amy.
Hello, I am Amy Henneke, and I lead the Northeast University Semiconductor Network for Micron Technology.
Welcome, Amy. And then I have Francis.
Francis Patrick McCluskey, go by Patrick. I'm a professor at the University of Maryland, College Park, looking at reliability of electronic systems.
Excellent, welcome. Next here I have Yi.
Hello, everyone. Greetings from California, Bay Area. I'm a senior director with ICAP's BU of Applied Materials. We are the equipment supplier.
Welcome, welcome. Great. Next here we have Drew.
Hi, everyone. My name is Drew Sherman. I'm the business development lead at SoloXR.
Welcome, Drew. Next, I have Fang.
Hi everyone, my name is Fan Wu. I'm a power electronics professor from Stony Brook University, and we also do power module packaging.
Very good. Welcome. Next, I have Carolyn.
Hi, everybody. My name is Carolyn Greiner, and I'm the founder of Optimize with Learning Solutions, or OWLS, and we're working with Robert on some e-learning support.
Wonderful. Welcome, Carolyn. And I have Shyam next.
Hi, my name is Shyam Aramudan. I'm at North Carolina A&T State University, professor at the Joint School for Nanoscience and Nanofuel. Also, the director of the facilities, the core facilities here. More part of lots of, with
Can you just repeat that last part? It cut off. Sorry about that.
Yeah, sorry. Yeah, I said I'm also part of the GLOSS ME Commons Hub, which is led by NC State, along with Jacob. I co-lead the workforce efforts for that.
Okay, great. Thank you. Welcome. I got Patrick next.
Hey, nice to meet you. I'm Patrick Wallenius. I'm the engineering manager here at CLAWS at NC State University.
Very good. Welcome. I have EKO.
Hi, my name is Eiko. I'm a PhD student at NC State. I'm working under Professor Hopkins right now.
Very good. Very good. Thank you. And last, I have Nick.
Hey everyone, I'm Nick Turner, the VP of Digital Twins at SoloXR, and we do coordinate all kinds of digital twins from NFL stadiums to factories and mines and everything in between. So really great to meet everybody.
Excellent. That's everyone, I think, went in order.
I think
I'll just take
Jacob,
one.
I think Jacob, I don't think.
Did I miss somebody? Okay. Oh, Jacob, my apologies. It didn't appear my
Maybe
screen.
others too. I don't know if Margaret was introduced.
No,
yes.
Margaret was in there.
To keep track of everyone. But Jacob Jones, professor of material science and engineering at NC State and co-lead of workforce development of the CLAWS program and ME Commons Hub, along with Sham, who you heard from earlier. Thank you.
Very good. Thanks. Yes, Margaret.
So hello, I'm Margaret Robertson. I'm the Vice President for Workforce Development at Central Carolina Community College. We work with Jacob and Sham with the NC State CLAWS program on the workforce technician side of it.
Well, good stuff. Welcome. Is there anyone else I might have missed? Well, that's a.
Did Amy?
Amy? Yes, Amy did
Okay.
speak. So we have really nice representation from academia, from the private sector. We have industry, and I think, and the public sector as well. I think this is an initiative that is extremely timely, as you all know, and this manufacturing renaissance that we're seeing is sparking up a lot of publicity, but also a lot of investment demand from both venture capital firms and from the public markets, but also a lot of investments and grants and incentives from the government. Even the recent bill, a 35% discount or credit for manufacturing is going to spur even more manufacturing here in the US. And what that means is and you're all in this business, so you understand, but I think even those of us that are understanding what's coming are going to be shocked at how crazy it's going to get, and it's going to happen quickly. And there's going to be a disorganized approach. You'll have ad hoc standards, you'll have regional standards, and then you'll have others claiming that they've got the best solution and so on. And through it all, depending on who gets the microphone, you'll have those that'll be declared leaders and things of that nature. I think for this initiative, having kind of an overall kind of mega plan of who all the stakeholders are. So you've got that trifecta of public, private, and academia, and then ultimately who all benefits from it, and each stakeholder has the own outcomes they want to achieve, whether it's better education or finding the right employee or optimizing and being more efficient, or even regional players attracting manufacturing, let's say in their state or even in their county. And all of these forces are going to have tension on everything that's happening. In the background, at the end of the day, we're talking about labor and operational efficiency and improvement. So we have to train the workforce. We have to, first of all, sell it we collectively, America, sell it to communities and provide access to communities, and so that there's an interest. And I think that is something that there's a number of initiatives on the way now. And then in parallel, once the interest is there, the K through 12 need to understand that that these are career paths that are worthwhile, and they need to understand what it might look like. And so then you end up with a pipeline from a supply side of students, and then into community colleges and universities and so on. Industry is going to dictate the demand in a lot of ways, and in terms of what talent they need and how much they want to automate or have roboticized, or keep here. And so the whole supply chain, and then the development of manufacturing and industry 4.0, 4.0 plus is, smart infrastructure, smart factories, all of that's going to impact everything we're doing. So when Professor Hopkins has this solution, and it's specific for packaging, but it's also a methodology that addresses a need even beyond packaging. And as the pilot proves successful, it can be adopted across America and regionalized too, based on market demands and things of that nature. So this particular NatCast funding grant is one avenue, but in addition to that, there are a lot of stakeholders that are interested in taking something like this and making it much larger. And so at SOLOXR, we're going to be working to help that become a reality. So while you launch a pilot here, and you may have a certain number of stakeholders with the pilot, in parallel, we'll be testing and modifying, almost like an A/B test in some ways, of what works best in rural areas or in urban areas, what configuration within the box should be automated, semi-automated, or more manual. What is more appropriate for community college, what can sit adjacent so that it's literally operational for industry. There's so much at play here, and so this initial meeting is so very important to lay the groundwork. And in parallel, of course, there's all kinds of pieces coming at this from different angles. We also have our learning partner Al's here as well, consulting to help to help as well from the learning standpoint. But then you have, again, we talked about IPC, you have you have the standards and the credentials, and hopefully, and IEEE, the ability to come up with new curriculum that would be needed to meet the demands of new of new roles based on where automation will be 5 years from now, because that also needs to be part of the plan and part of our blueprint. And then all of that within that, how does XR fit into that? Is it providing training for the virtual factory, or for a smart factory, and then on the AR with the overlays for working with a lot of these highly integrated IoT sensors with some of the things we're seeing now. It's coming, and there's a lot of examples I'm sure you've all seen already. How do we integrate that into a curriculum? But then also, if it is an automated machine, a robot, how do you go in to show what sub-processes that are automated, what it actually looks like on the inside, and how can you create a visual rendering or representation of those component parts in there? And so there's so much potential here. And then again, that rural economic development and workforce development, giving access to rural communities and giving them a pathway for full employment is going to be important. So having said that, this is going to evolve quickly and regionally in various regions across America. And is early on is going to be heavily reliant on academia to test, prove, and then, and then there's the opportunity to leverage public funding through grants and other initiatives. And we'll be able to test a lot of things. So I encourage this group to continue to be innovative, to ideate. This solution might be 100% where we end up. It might only be 70% where we end up. There may be components that need to be modified or changed, or there may be market forces we aren't even aware of yet that will impact how we do this, from a mandated learning, things like that. So it's a really exciting endeavor, and as I said, funding will be available, and that shouldn't be an issue. Really, what we should do is come up with the best solution to address this workforce crisis and a skills gap here in America. So that's kind of the message I just wanted to paint right now.